So what's the plan with the basket case old Murphy, which it looks like there's a serial number here which says A1669, and a lot of the Murphys, they seem to start with an A number, but they're only 3 digits, not 4, and I can't find anything on this thing at all. So no circuit diagram. I mean, I could probably look at quite a few, but I'm not really that bothered. I mean, you know, they're all what I'm planning on doing for it to make sense. Why I don't need a circuit diagram at this point is what I thought I'd do is just test the voltages that for the mains transformer, so that the primary and the secondary can actually don't short within themselves. And without the rectifier diode in, there should be no power to the DC side, except for the windings for the heaters and possibly the bulb. And I've tested this bulb and it's actually okay. So what I thought I'd do, using the dim bulb tester again anyway, because obviously that's the whole point, it's inherently safe. I've taken a couple of precautions before I do for later, should I decide to go further and actually put the rectifier valve in, because what I was thinking is if there's nothing totally tragically wrong with this first set of just really basic tests that don't involve the rest of that horrible circuitry in the radio, just show basically what the rectification looks like on a valve rectifier diode. I mean, yeah, you could go on the web and stuff, but it's just all part of, you know, a bit of interest for people who want to look at this stuff. And as today, this arrived, which you can't really get in shot, which is about 3 weeks early from China, so I'm pretty impressed. But this is the Finersi oscilloscope and combined signal generator, so that was an unexpected bonus today, and I'm glad I didn't go out or sort of miss the person. So I now have an oscilloscope, which should make life a bit more interesting for future videos. So for this one, what I'm thinking of doing, I've soldered, because the wiring, as you've seen, is in such a horrendous state. I've hard soldered, I've put some shrink down on the really crappy bits of insulation here, and these are just the primaries of the primary winding of the mains transformer. And I've tested the mains transformer and it's coming up about 34 ohms on the B-side tester, so there's nothing wrong with the primary. I've also attached an earth cable and soldered it to the actual chassis, so in the worst case scenario, if anything shorts out, there is a connection to ground, which obviously through the dim bulb tester shouldn't be a problem anyway, because as we've seen, the whole point is to take all of the current and all the load across the 25 ohm dim bulb. So I'll set that up in a minute. Just a couple of things for later. These caps that go onto the older style valves I've taped up, because some like this one, the top of the cap is actually grounded, but the inner core is what has B+ on it when it's feeding the valve. So I've just tied this one out the way. I've tested it. There's no short between the center and the outside is attached to the chassis, so there's good connection there. This one, I've cut the cap off to save me soldering it. I had to put some shrink down here to stop it shorting out on the edge of this can, so that's okay. And while I'm moving it around just for these first set of tests, I've shrunk down over the actual wire that feeds the anode, so that when I'm tipping upside down, that can't short out against anything. And I've done the same with a bit of tape for this one and tied it to this wire so that can't flap around, maybe if I decide to do any further tests, depending on what these ones are. Again, just for the sheer hell of it, to see what happens with the safety of the dim bulb tester, with this unit, you know, just see how far it actually goes before, you know, basically either caps start smoking or whatever might happen. But that's not going to be in this video, else it would be, well, I'm just not ready at that stage. So, to recap, what I've decided to do is do just at least the first mains bulb dim bulb test using the 25 watt bulb, with the power meter in conjunction, which I wish I'd done the tests on the last video with the power meter, and that would have been interesting as well. But anyway, so I know the primary is okay. I don't know the state of the secondary of the mains transformer. So all that should happen in principle with this is, with no rectifier diode feeding the actual rest of the circuit, nothing should go onto the rest of these components. The only thing that should possibly work, if the heater's winding is in conjunction with the bulb, or it may be a separate winding, but it doesn't look like it. But without a circuit diagram, I don't know for sure, is that the front panel bulb should light up, because obviously the 6.3 volt winding on the main secondary, assuming that's okay and not shorted out, should actually feed power to the bulb. So if that wiring is even okay. So there's a lot of variables involved here, and so it should be interesting. So I'll pause the video and I'll get the dim bulb tester set up and just see what happens. See if there's any, well, just don't know, and just basically be really careful moving this thing around. That's why I want to get it set up and not have to move it again while I'm doing this set of tests. So I'll get that set up, and we'll get the first 25 watt bulb in, and go through the set of tests that are just testing the mains primary to see if it can even hold full mains voltage just on the actual transformer primary, and then whatever's attached to the secondary, if that's working, just to see that the actual windings of the mains transformer can handle full mains voltage or not. Right, I've got the mains, the dim bulb tester set up with its test shorted pins plug to actually test that everything here is functioning before I plug in the actual radio to the dim bulb tester. So I'm just turning on now, and there's the 25 watt bulb, so we know that's fine. So let's whip the shorted plug out and put the radio in, and let's see what happens for the voltage that will be applied by the 25 watt dim bulb, and hope there's no smoke or fires. Right, well, incredibly, the light has come on the front panel, so that's the dim bulb is actually, so the panel light is actually working, and we've got 7 watts being drawn, 8 watts being drawn, 7, 8, it's flicking around here, so about 8 watts just being oscillating between the primary and the secondary of the mains transformer. So not even a short on the 6.3 volt windings for either the heaters and certainly the bulb if they're combined. I don't know without circuit diagram, but usually the bulbs are incorporated in the AC circuit that comes, that's off the about the 3 amp 6.3 volt heater circuit, and any bulbs, panel bulbs. So far so good. Okay, here's the 40 watt bulb. And seems to be drawing the same 7.1 watts, bouncing around a little bit. So let's just flick up through these pretty quick. Okay, this is a 60 watt bulb, and again the same low wattage obviously, because it's just put, in principle there's very little load on the secondary, with only the 6.3 volt winding pulling anything across from the primary. Right, so now the 100 watt bulb's in. Obviously, I don't expect anything really to show any more than this, because there's just no load being applied. It's just to, find out whether the internal insulation of the primary can actually handle 240 volts RMS mains in. So that's the 100 watt bulb, and now the 150 watt bulb's in. So again, the same wattage, because it's only the the power through the slightly well, it's gone down to 5.3. So right, what now? I'll let me have a think about it and see what I'm going to do next. And well, of course, the thing to do now is actually test it on the mains. So she's plugged into the mains, and obviously we'll have to see, just to do the final check to see if this mains transformer can actually handle a full 240 volts across it, and see what happens. Here we go. Right, so the mains transformer, certainly the primary, is in good enough condition to actually take steps a bit further.